Across Newcastle and the Hunter, 2NURFM 103.7, 2023. We're well into it now, and it's time to start bringing back some of our guests. You know them, you love them. And our first one, day one, door number one, is our Professor of Science from the University of Newcastle, John O'Connor. John, great Christmas and New Year's and Australia Day and all of that for you?
Yes, it's been a great period. But then, being retired, I can do that. No, I don't have to worry about coming back to work.
Yeah, but I'm sure you're like most people that seniors, they get to that point and they're like, no, I'm busier now than I ever was.
I wouldn't say that I ever was, because I used to be really busy, but at least I can now say no to the things I don't want to do, and that makes a big difference. It means I can just do the things I enjoy doing,
that's
like
this. That's that one thing. If you just decide, I don't want to come in anymore, like you don't enjoy
it.
That'll be the reason.
Once I get fed up, yeah.
Today we want to talk about something that does have a lot of longevity, and that is some of the particularly architectural feats of the Romans. Some of their buildings, some of their roads still being used today. There is a couple of secrets though in the concrete.
That's right. There are buildings that the Romans built 2,000 years ago that are still fairly solid. They're still solid. They're more solid than some of the apartment buildings built in Sydney. And there's been a lot of uncertainty about how the Romans built these things that lasted so long. And they had techniques we still haven't worked out, how to make concrete that sets in seawater. But the one,
if you can figure that out, get back to me.
But the one in particular is one that they thought it was just a mixture of volcanic ash and lime, and that's how you normally make concrete. And they couldn't really work out what was so special about this. So a group at MIT really threw all of the analysing instruments they could come up with at it, and they found that there were small chunks of limestone in the small chunks of lime in the concrete. Now, what they normally do is they create lime from limestone by heating it up. They then mix it with water, then mix it with aggregate and so forth, and off you go. They found these chunks of lime in there and they thought, gee, they're a bit sloppy. They didn't quite mix it up properly. But it turns out that was the secret ingredient, and it was deliberate. And what's more, they didn't go through the normal process. What they did was they mixed the lime and the volcanic ash and then put that into the water, and that gets really hot. And what that does is, first off, it keeps some small lumps of lime in there, as well as producing chemical reactions that don't happen at lower temperature, which means that the whole thing sets quicker, which is an advantage. But having these small lumps of lime in there are the key, because what happens is if the concrete starts to crack and water gets in, it gets to the lime, converts it to calcium carbonate, and seals up the crack, so it stops it propagating any further. So if you look at a glass window, your windscreen of your car, and you see a crack, you'll see it gradually propagate. If you don't do anything about it, it just gets longer and longer and longer, and of course it goes right
away
through.
You go.
And the same thing goes with concrete. If you can stop that crack, then it'll stop propagating, and it'll remain fixed. And so they came to the conclusion that it was this lime, and of course, if you come to that conclusion, you've got to test it. So they went ahead and did the same thing. They made 2 batches of concrete, one the more traditional way and one this particular way, and then they deliberately cracked it. About a 0.5 millimetre crack, left it out there in the weather for a while, and they found the calcium carbonate got in there and it filled the crack. So yes, it restored, or it healed the concrete once it started to degrade.
I always wonder, John, when we were talking about these ancient techniques that were obviously very well widely used and accepted at that time, then all of a sudden one day they're not. I mean, what you kind of wonder what the break is there, that because obviously it worked.
Yeah, but if you look at the tumultuous history of Italy, they got invaded at various times. People came in, probably killed the master builders or something, or some of these things are lost, or maybe the materials weren't available. But yes, certainly there are things that have been achieved in the past that surprise us. And there's the thing called the Antikythera, which is a small mechanical computer which was found in a ship. A sunken ship off the coast of Greece. And this is a marvel. I mean, it's something that couldn't have been built subsequently till about 1900. And so, yes, certainly there were people back then were as smart as we are now. It's just they don't have the history of knowledge behind them. It doesn't mean they weren't clever enough to do things.
Yeah, there's always a day one, isn't there, where somebody comes up with an idea and hopefully we're now at a stage where we can go back and rediscover a lot of these ancient technologies.
And take advantage of them. And this particular discovery is great. I mean, make concrete which work quicker. Maybe that's not a good idea if you're running around the back of a concrete truck. But anyway, but also it may be something that's worthwhile in terms of trying to create a structure that is not as fragile and will certainly heal itself if there are any fractures.
Maybe for road building as well. Just a bit of a thought there. John, it's always a pleasure. We'll talk to you in a couple of weeks from here.
Thanks, Mark.
All right, there he is, our Professor of Science from the University of Newcastle, John O'Connor at 2NURFM 103.7.
A broadcast service of the University of Newcastle.